Next, I need to create the outer edge of the part. You may want to think of this as the parting line of the mold for the part, since it often corresponds to that. This outer edge is a 3D curve, and although it could be drawn with a 3D spline, that's too difficult. I want to be somewhat more precise than a 3D sketch allows. Now I already know what this edge looks like from two different directions, from the top and from the side. With this information, the best thing to do is create a projected curve. To create the top view of the part, open a sketch on the top plane. If I had a picture of the part from the top, I could use that here in a way similar to the way I used the picture of the side view. Now I don't have that information, so I'll need to use some design license to come up with a suitable shape. I'll draw half of the top view of the part. In this case, I've drawn a construction line and dimensioned it to just serve as a guide. Now this dimension does not drive the part. It simply represents half of the width of the ball. The endpoints of the spline connect to the origin on the left and the sketch point on the right. You can identify the sketch point because it's the rightmost sketch point available. Remember, a sketch point has the appearance of an asterisk, not a solid point. The spline handles at the ends have horizontal relations to make the spline go smoothly across the plane of symmetry. Notice that the sketches created with splines are generally not fully defined. The fewer spline control points you can use to create the shape, the better. Shapes are usually smoother with fewer points. The highest density of points should be around areas of the largest curvature. That is, the area having the smallest radius. You may want to examine the spline using the curvature comb to make sure it's as smooth as possible. Now I exit the sketch and rename it as Top Projected Curve Sketch. When working with complex parts, it's good practice to rename key sketches that you may need to come back to at some point.